Is there one more handheld? Thank you. All right, one on this end, one on this end. That way y'all can trade. All right. So this is going to be a fairly casual panel. My name is Cassandra. I'm a program manager at Google. I'm also part of GoBridge, which is the diversity organization for Go. We're going to talk about a couple of topics, but first, we're just going to have everyone introduce themselves and where they're from and their company and your name. So we'll keep it really short for this round. Do you want to start?
Yeah, hi. My name is Shriti Shikhar. I'm from Bangalore. I work for Red Hat, and I work in Golang on developer tools. And I've been organizing Golang Bangalore meetups in Bangalore for past about 1 year. That's all.
Hi, I'm Niranjan. I work with Gojek, which is an Indonesian startup. I'm working out of Bangalore. Been working on Golang for last 3 years. Yep.
Hi everyone, Matt Ellis with Tibco Software out of Palo Alto, California. I'm a product manager for our open source project, Project Flogo, which is Golang based.
Oh, Flogo fans.
I'm Aditya. I am an observability engineer at Stripe, and I've been writing Go for 6 years now.
My name is Sean. Everyone calls me Stabby. Hi. I work in Boston for a company named Rapid7, and I am an engineering manager for the security, automation, and orchestration team.
Hi guys, I'm Bill Kennedy. I work at Arden Labs and pretty much training in Go every single week.
Yeah. All around the world too. All right, so we're going to start off with a topic about tools and education. And then after, we'll open it up to all of you. So feel free, now that you've gotten a little bit of an intro to our panel here, start thinking of some questions so that maybe in about 10 minutes we can get to some of them in the crowd. If not, don't worry, I have backup plans, which is just more questions. So to begin, I'd love to just hear from the panel, what were you doing before Go, and why did you choose Go, and what challenges did you face?
Should I begin? Okay. Before Go, I programmed a little in Python, and the challenge I faced in the beginning was setting up GoPath.
Yeah, yeah.
I have worked on different languages. I started my career with COBOL, then shifted to ABAP, then did Java for some time, did Ruby for a long time, JavaScript, did a lot of Clojure. Almost for 2 years I did Clojure, and finally landed on Go. Even right now I actually go across multiple languages. I'm not purely on Go itself. When I started working on Go, first few things which essentially struck me was, one is multi-returns from a function, right? That is not something you follow in a lot of languages, and getting used to that took some time. Second thing which was really interesting and it took me some time to get adjusted to is the way Go goes about defining interfaces and the overall inheritance structure itself, right? It's unlike any other object-oriented system, and you need to essentially wrap your head around how to structure your program in Golang, and it is not same as other object-oriented languages. Like, to give you an example, like coming from Ray's background, on my first Go project, I tried to implement active record, and that was not a good idea.
So before Go, at Tibco, we use a lot of different languages for different projects, right? So Java, there's some .NET stuff, there's C stuff as well. There's all kinds of different languages used at Tibco. But what we initially did was we set out to build a framework that was targeting IoT devices, and we essentially came to the conclusion that the existing languages that we use within the company really wasn't well suited for IoT, which led us down the path of Golang. Some of the interesting things I think we've ran into with Go is definitely the lack of OOP, right? I mean, that's something that you gravitate toward, especially when you come from Java or C++ or .NET, things like that. So the lack of OOP, the multi-return value, the not having exceptions and things like that was different, but a good different, I would say.
Before Go, my primary languages were for general purpose programming were Python and Lisp. I used R a bit for stats as well, but not for most other stuff. And so for me, when I was coming to Go, this is also in the Go 1.0 days, the biggest problem is that Go is a very opinionated language, especially coming from Lisp, where it's the exact opposite of an opinionated language. In fact, it can't even decide on what language it is. Coming to Go, where there is really one right way to do things, and you can try to work around them, but you're just going to make your life more difficult and be unhappy unless you actually do things the right way. That was a huge shift. In the end, it was fine, but it definitely took a huge amount of adjusting to, and particularly in the early days, there wasn't a lot of great just resources or communication around what that really meant for programmers from other languages.
So I came to Go from writing Ruby for about 4 years. And some of the challenges I think that I initially faced when writing Go was a lack of, at the time, what I saw as expressiveness from Ruby. So Ruby, almost sort of like how you described Lisp, there's a million different ways to do everything, and they're all right or wrong depending on which Ruby developer you happen to speak to at the moment. And so there's a lot of things that you sort of lose when you move to a language that is, by design, a lot simpler and more straightforward to write, like Go. But over time, I came to sort of appreciate that a lot, and I sort of agree with Aditya, which is that there really is one right way to do almost everything, which does simplify things a lot and make things a lot easier. External to myself, I think one of the challenges that I initially faced with Go in selling it to the rest of the organization was they were a bunch of Ruby developers, maybe some Scala developers, maybe some Python developers, who didn't agree with things like GoPath or some of the missing pieces of the ecosystem, which we're still struggling with today, like dependency management. And so trying to sell those to other members of the team was a little bit difficult. But when you show them performance and the ease of maintenance and things like that, you slowly start to win over more and more folks, especially the more curious of the engineers who are looking for new languages.
So I was developing software on Windows for a little over 20 years, and in order for my company to survive, we had to move to Linux. And that's when I found in 2013, that's when I found Go, which I was very depressed about before I found Go, because I thought, oh my God, I got to be a C developer again. So there I am in 2013 learning Linux and Go at the same time. It was a fairly depressing 6 months. And now we are where we are. So I think the biggest struggles I've had, and I still have today, by the way, is understanding project structures and packaging. I think this is just such a foreign concept that we're not taught, and so far away from all the object-oriented kind of aspects of how you organize source code, that we're all struggling. Everybody in this room and everybody outside of this room is struggling with project structure and packaging, so don't feel alone.
Awesome. Let's bring it actually right back to the end and talk about education tools. I've had a lot of people come up to me and ask, where do I go to learn? So in your opinions, what are some of the best education tools that you've seen out there? And that can be anything. That could be specific people who have blogs that you love, videos, sites, and maybe you have some of your own that you'd even like to share.
I think this one's super hard because everybody learns differently. There are some people who love to read and they just want to take their time. Some people need video. I just find it really challenging. And I always have to ask somebody, how do you learn best? Mm-hmm. And we really have, I think, over the last few years, a really nice set of blogs and videos out there for what you want to do. When people ask me this question, the first thing I think about is if I wanted to learn Rust, which is something I do want to learn, right? I'm completely clueless about Rust. Where would I like to begin? And I love the idea of the playground, and I love the idea of the Go Tour. Mm-hmm. But what I've heard about the Go Tour, and I haven't looked at it, is it starts out really well, and then it just kind of falls off a cliff, you know? So for me, if I think about I want to go learn Rust, I would love if there was a Rust tour that really took me all the way through. And then I think from there you'd want to try to get a sense of what don't I really understand, and then some blogging. I like reading much more than video. I've got to watch video at like 2x all the time, and you can't do that with me. I talk really fast.
No, you can't.
Can I answer that?
Sure.
So reading blogs and books and everything is definitely helps. One thing that has really helped me is following the logs on the Slack channel, Golang Slack channel. I come to know about various new things about Golang through when people reply to a particular person's problems, issues. So that's how I learned. So I think that's really helpful. That's all.
Yeah, it's a great resource. Anyone else have resources?
Yeah, so I sort of mirror some of what Bill said, which is, everybody learns differently. For me, I'm a very hands-on learner. I do like to read a little bit more than I like to watch video, but ultimately, at the end of the day, for me to learn, I have to do something, or else I just won't internalize it. So typically, when I wanted to learn about Go, I would pick some problem that I had in my day-to-day job, or something that I was working on the side, and I would just choose to do that in Go. And again, I think this wouldn't work for everybody, but for me, I would just brute force my way into a solution, and then over time, iterate on that to improve, syntax clarity or idiomatic representation of the code or things like that. One of the first things that I wrote in Go just for fun was a very lightweight networking service that would just shove protocol buffer messages over a pipe. And I used that to learn a couple of different things, protocol buffers in Go and networking in Go. And what I found was it was actually really easy to go through the Go source code itself from the entire networking package to learn exactly where the errors were coming from, how to work around certain problems, what I should expect when TCP backflow, back pressure kicks in and that sort of thing. So for me, just kind of brute forcing my way through problems and learning by doing has always been the most effective. And finding blog posts that are tangentially related to a thing that I'm working on are usually a good starting point for me.
So Go's source code is fairly readable. Once you know Go, learning like more intermediate and advanced forms, the best way I found is to just find open source projects and to read more Go and figure out how they work and learn from different approaches. And this is something that actually wasn't really possible to do with advanced Go until relatively recently, because for a while there weren't that many large projects written in Go, at least open source stuff. In fact, even the Go compiler itself wasn't until a few years ago. And now we don't just have the Go compiler, but we also have a lot of other really large open source projects. Like in terms of lines of code, Kubernetes is, at least certainly in compile times, it dwarfs the Go compiler. And you can see that these are all projects that have people who have significant amounts of Go experience, but slightly different takes on how it's done, how things like packaging and package layout, for example, are done. For me, that's the best way: is just reading source code and finding other projects.
Yeah, I would tend to agree. I mean, I typically like just reading source code, Googling things. I definitely love the playgrounds, but more than that, I like just hacking at stuff, right? So that is the beauty of Go, right? It's that that elegance and simplicity, right? So you can read the code, you understand you get a good grasp of what's going on. You pick up some of the caveats of the language and things like that just by reading the source, hacking at it. And playing with it. Just from a kind of a tool perspective, there's an online resource, Katacoda, which I also found to be pretty neat in the sense that you don't actually have to set up anything on your personal machine. It spins up a virtual environment for you, and you get access to a shell, and you get the Go path and everything installed for you, and you can walk through tutorials without actually committing to anything on your machine as well, which is kind of neat.
Oh, that's interesting.
So now my job is fairly easy, right? +1, +1, +1, +1. So I agree with Sean. My way of learning a new language is I actually like to read code, what other people are writing, and understand what are the standard patterns and practices which are followed. Now, with Golang, as Aditya was saying earlier, there is one right way to do things. And to find that right way, you don't have to go too far away. You can just dive into the Golang code base itself. And you can look at how things are done there and start learning from there. Apart from reading that code base itself, other thing which will help tremendously is understand the concurrency patterns, what different concurrency patterns are there, because that's one of Go's strong suit, right? So actually going and understanding those patterns and then mapping them how Golang uses that is a great way of going about it. Also going through other languages, like for example, Clojure has implemented GoChan in Clojure as well. Looking at how they are doing things and then comparing that with Golang is another way of essentially picking up nuances and nitty-gritties of what is possible in Go and what is not possible in Go.
Awesome. All right. So, what would you like to see out of Go the most? What do you need from Go? And you can be as long or as short as you want, but I may cut you off because I've had this conversation with some of you, and there's a list. And we can start wherever, maybe somewhere in the middle this time. Yeah, putting you on the spot.
Sure. So I'll keep it short and sweet. So committing to the I think the plugins, right? So actually committing to that and dynamically loading, Go packages is awesome. The fact that the plugin capability only works on Linux and is pretty finicky is a bit annoying. So I'd just throw that one out there.
I would love to see a proper decimal type.
I'd like to see Go's dependency management evolve further and moving more towards canonical versioning instead of Git-based versioning. Because whenever you're depending on third-party libraries, canonical versioning is something which has evolved over years in computer science, and people understand what it means when dependencies break, when they don't break, and sticking to that would be much better. Second thing is, I really hate the way Go dictates how I should structure my folders on my machine. My VCS structure and my machine structure, I want it different because I want to arrange my thoughts into my folder structure in projects, and how do I want to, couple them, group them, and the fact that everything needs to sit on Go path kind of destroys that.
I don't think I have anything new, really.
I think I agree with Niranjan. Better dependency management would be something that's...
Mm-hmm.
So Go, I think Go is like 6 years old now. It's like as a in stable form, and we've seen it grow up in a lot of ways as a language, and that's a good thing. Like we've seen it gain adoption at very large companies running it at like pretty large scale, but we still have a whole ways to go. And right now, from a language perspective, I think Go is actually pretty solid. But there are a number of things that if Go really wants to win, truly win the cloud, we're on that path, but we haven't actually won it yet. If we want to win the cloud, if we want to win at the enterprise level, there are a lot of things that we'll need in order to get buy-in from CIOs, CTOs, and things like dependency management for build stability is obviously a big one, but it's only one of many things. There are also a lot of other aspects of it, like the management of the language and its community, some parts of which are still open questions. That's really what I'd like to see Go focus on for let's say the next 6 years, as opposed to what we've been able to accomplish in the last 6 years.
What did you mean by management of community?
Sure. I would say Go's.
Repeat the question?
Oh yeah, the question was, what did you mean by management of the community? Go, like the relationship between Go is an open source project, and there are a lot of big players who contribute to it in different ways. The relationships between all those different players. Obviously, Google is a big one, but they're not the only one. They're at this point not even the only large corporate. They're not the only large corporation that has significant contributions to the language. And it's not that there are active problems there, but there are definitely a lot of aspects of managing that relationship that as we've grown, we now need to start to address because we need to be able to do that in order to scale as a community. Sure.
I can dig it. All right, do we have any questions from the crowd? Questions? Raise your hand. Someone will run to you with a mic or walk fast. Oh, are there? I looked at them earlier. So let's take the one from the crowd, and then I can check out these.
What are your thoughts on generics in Go?
I just knew someone was going to ask that.
We have generics. We have the make function.
That is often the answer.
A less, I guess, sarcastic, I don't know, response to that. Actually, no, I mean this in all earnest. At the very first GopherCon in Denver back in 2014, there was a panel with a number of the Go authors. And someone asked that exact question, and I believe it was Andrew Durand who said very succinctly, we do have generics, they're called interfaces. And it's true that interface types are not the way that people are used, they're not one-to-one with generics from, say, Java, but they do actually address a lot of the same problems. You have to approach them in a slightly different way. It's not, you have to learn how to use interface types in a way that will allow you to solve generic problems, but it is true that that is the Go approach to it. It's not generics, but it is the solution.
Crowd questions. Oh, I don't know.
Yeah, I work for a company that seems to want to move everything to Golang, and I'm not complaining, but what that means is that sometimes I'd like to write DSLs, domain-specific languages, in Go, more expressive stuff, and that's not something that Go lends itself very well to. Do you think that's one way forward for the language? Did that question make sense?
Could you repeat the last part of that question?
Yeah.
I pulled it up on my phone.
Do you think Golang would lend itself well to writing domain-specific languages?
No.
Yeah. I would also say no. Sorry.
To be entirely to give you a slightly longer answer, I think that's a feature, not a bug. I came from Lisp, which is very much DSLs are arguably the entire language is writing your own DSLs, and the problem there it becomes maintenance, and especially as you're writing software like that scales between 2 developers to 1,000 developers on a single team, DSLs in my experience become more of a liability than anything else, and scaling software from larger number of developers, not users but developers, is one of Go's strengths, and I don't think it's a coincidence that Go does not embrace DSLs.
Like I said, I came to Go from Ruby, and I think Ruby is pretty excellent at writing DSLs. Not for serious production use, but a favorite pastime of mine in Ruby was I would just write a DSL to solve a problem just because I thought it was fun. But I agree with Aditya that it's much more likely a feature, not a bug, that Go is just not designed for that. And I think that's okay. I think one thing that we need to keep in mind is that Go isn't the language for every single thing, and it's okay to use different languages for their intended purposes. So I think that's where I would go with that.
I'd actually like to extend that, right? It's not just about Go, but every language has its own sweet spots, and it is meant to do something. And whenever you're choosing a programming language, you need to understand what is the problem you're trying to solve and choose the language appropriately. Go has certain philosophy. It optimizes for certain things, which means that bringing any and everything into Go will just dilute the language, and it will make it so complicated that it will lose its simplicity. And same holds true for any language, right? Like if you look at Clojure, it has its own sweet spot and strong points. Same with Ruby. Like if you want to write highly performant concurrent code in Ruby, no, you're choosing the wrong thing. But if you want to write really expressive and something like DSLs in Ruby, yes, that's what the language is meant for. Go is not meant for that, and I'd prefer it stays that way.
My question is, what about the debugging? I know printing is a way to debug, but apart from that, much better tool. And second thing is REPL and something to do with monitoring, because though there's pprof and tracing, but still it's not that user-friendly.
I'd say for debugging write tests, you don't need debugger.
Okay, as in, okay. Yeah, sure.
GDB is an option if you don't need to debug stuff that is Go routine aware. I can speak a little bit more to the observability of Go programs, since that's more or less what I do for my job. In that aspect, I don't think Go is particularly unique. Go lends itself nicely because there's a lot of great support and tooling for it within the language and also outside the language. But I would encourage you to think about it from the application perspective, like an applications or systems perspective, as opposed to specifically at the language level. If you know that you do need to actually profile things within the language, obviously, as you said, like there is pprof, there are a number of tools that we can use. But by and large, Go is meant for writing large systems, and it's good at writing large systems, and it's very easy for us to focus on observability and monitoring at the language level and forget how to do it at the application or system level.
One thing I'd add on the note of debugging, there's also Delve, which has come a long way over the years. It's a lot easier to install and use now, and it's by default integrated with a lot of popular editors, so there's that as well. One other thing is I'm lucky enough to help organize the Go meetups in Boston, and we have access to members of the compiler team there. And a couple of different times they've come and spoke about specifically improving debugging information. So things that relate to Dwarf and ability to use GDB and Delve and that sort of thing. So it's always getting better. And so I think while some people have very strong opinions about not needing debuggers, if you want one, I do believe that you should be able to use it. And the compiler team seems to agree because the story is getting a lot better there.
So actually, I moved to Golang from Java background. One feature which I miss in Go is mostly streams and easy data manipulation, in which sorting, filtering, map reduce kind of things. So what are your opinion? Should it be there in Golang? What are the alternatives? Right now, even to sort, due to you either have to you have to write this for again and again for the different functions. There is no easy way to do that. Any thoughts on that one?
I mean, so for sorting, it's true that it probably takes, maybe 3 more lines to do it in Go than in Java. But on the other hand, verbosity, verbosity is not necessarily like the biggest pain point. I guess
the problem I see is it breaks dry most of the times. Even to implement the basic functions like deleting an element from an array, as simple as that, and sorting, which I feel is the bare minimum functions. I somehow have to write too much of the code, and then again it comes back to generation. Go suggests do generation, but
actually I could answer that one. Yeah. So I've asked this question. I was having this discussion with Dave about it. This is where this is the beginning of generics. So once you want to sort it, then you want to reverse sort it. Then when you want to sort it, I want to sort it with a particular logic of my own. Then when you want to sort it with a particular logic of your own, you also want to have exceptions in that. And once you start this trend, it starts becoming a lot of generics, which would actually add a lot of load on your library. And when you're adding a load on your core library, you're adding a lot of functionality.
So I think when it comes to customizations, that can be solved using Lambda. For example, there are sort functions in which for a type you pass a Lambda, and it just takes care of that one. But even the very basic sort, and even if it implements it is simple.
So when you sort it, you'll have to sort it with a data type, right?
Yes.
I don't want a data type because I want it generic. So you put interface, a generic interface. That's how it starts. And that's where the pollution begins.
Maybe what I'm looking at is, okay, there is a middle ground, no generics, and not to write sort every time, but is there a way how other guys do?
There is an opinion in the crowd?
Yeah, sure.
Yes. Oh, there is.
I mean, I feel very strongly about this because I feel that between always writing how to do it versus what to do it, the declarative versus the imperative way, I'd rather choose the declarative way, which is, in my opinion, in most cases, involves less cognitive load and it expresses things better. And I don't think that Go has to be that opinionated where it cannot actually have, high-level constructs for things like looping or things like iterating. And I don't really believe that's polluting. Of course, that does make that does depart from Go's supposed origins and it's a philosophy of keeping things very simple, for keeping the entry bar low for regular students to come in and immediately become productive. Maybe there is a trade-off there. I fully understand that, but I don't think Go really needs to be that opinionated about the what versus how imperative versus declarative way of expressing things?
I mean, I think the problem is you can't be everything to everybody, right? So there is a trade-off, and being opinionated in this day and age is I think, incredibly important. Otherwise, you start to pollute your own concept and your own image, and you damage what you initially created. So being opinionated is incredibly important. It should be a stance that you don't deviate from lightly. So I think it's important for Go to be opinionated, and I mean, there's plenty of packages that you can find to do some of this stuff, right? I mean, find a package.
Anyone else want to weigh in on should Go be so opinionated? Question.
So I'd say it's kind of required for a language to be opinionated, right? If you look at a language like Go or any open source language for that matter, opinions of this sort is what essentially binds the community together and tells them what is acceptable and what is not acceptable when you are building a language. If you drop those, suddenly different parts of the community will start dragging language in completely different direction. And that will dilute the overall language itself in so many ways that it will stop being simple. So that opinion, yes, as saying earlier, right, there should be a place to debate those opinions. But once the debate is done, you choose one and you stick with it. You cannot keep flip-flopping. Otherwise, the project suffers, the language suffers.
All right. No other opinions on that. Pun intended. We can take one more question from the audience.
Yep.
All the way in the back. Oh, you have a mic already. That's convenient.
The file system has an interface and ability to add new network protocols without maintaining a fork. For example, I needed SCTP and I had to use a fork of the Go thing because you can't add a new protocol into the language without maintaining a fork.
What's the question again?
So ability to add a new network protocol like there's TCP. If you want to add something like SCTP, you have to fork the language. Like the Go team was not accepting SCTP into the language, so somebody had to maintain a fork and I had to use that. And the second thing is file system as an interface rather than actual type, the file type.
Yeah, I don't know if that, the last question, maybe someone could pull at the end. The first question feels more like they're just not doing that. So there's not really, right?
That's something I want to see in the language to extend it.
Gotcha.
Sure.
Any other questions? Okay, last one right here.
Yeah, hi. So I come from a background of Elixir and Erlang. So you can consider Elixir as a hybrid of Ruby and Golang jam-packed to taking good stuff from both the places. So one thing I felt like there is this DSL and there is this generics, and I totally understand generics have really bad background. And so I took this generics concept and thought of like, okay, can we do something which does not use generics but rather than gives the same features like what interface do. So Elixir solves this problem by doing compile time code generation, which does not have any intermediate outcome. So in Go generate, we have this concept of generating code, right? But it gives you an output, which is itself a Go file, which is fairly not readable. And then, because that's the intention, right? And then at the end, you finally compile that code. But there is an intermediate step, which is not transparent. On the other hand, is there a possible way where you can like maybe use macro or something like that to have maybe add your code which can create Golang code in the middle and then finally you can just, it's a single step process. Would there be a consideration?
So I don't, if you have a proposal for adding generics to language, I mean, there are three large categories in which those fall into, and the trade-offs between them have been discussed. So I won't go into that, but in terms of the meat of your question, which is macros, macros are very powerful, but they're also very difficult and very dangerous. Macros, I think the only language that I've seen that really does macros right is Lisp, but Lisp can only do macros right because it's a homoiconic language. Go is not a homoiconic language. And so homoiconic means that the structure of the code itself has a one-to-one mapping with the internal representation of the code. In other words, Lisp, when you write the language, you're writing an abstract syntax tree. And so it's very easy to perform operations on Lisp source code and know exactly what the outcome will be on the AST because there's a one-to-one mapping there. There aren't really any other homoiconic languages that are particularly popular. Go is very much not one of those. I think macros without homoiconicity are a recipe for a large degree of complexity, which can become, again, very difficult to maintain in large-scale systems and would undermine Go's core strengths.
So one thing that I've run into at my current place of work is when we build a product where you can wrap other tools and incorporate it into our product. To do that, we have an SDK. To do that, you have to sort of define the structure of what the inputs and the outputs and the functions in that product you want to wrap are, which in a way you could say is sort of a perfect fit for programming generically. One thing that we did to get around that was to use Cogeneration. But that's not necessarily a built-in language feature. We just have in our own build process a step that knows how to interpret the certain files, these spec files, and to generate the structure of the code and to allow a user to plug in custom code on top of that. So we sort of use Cogeneration to get around setting up generic structures so that specific implementations of certain features like calling one API versus calling something on a CLI versus doing some basic math on your own can all be wrapped under a common interface, but it's built in a very sort of replacement for generics way where 99% of the code is always going to be the same, but it is the way that we got around it was it's very verbose. So there's lots and lots of boilerplate that a human being doesn't have to write or maintain, but that the system generates for you, sort of like what you're saying, and almost sort of like templates from C++, but not as an official part of the language. And I think where I am right now is I sort of see code generation either inside the language itself or more accurately, or rather more readily, outside of the language as part of your own build process as sort of that workaround to programming generically.
But being outside means that you have to pay the price of having debugging issues.
Yeah, true, yeah. Yep.
Any more input on that? All right. Thank you, panelists. Let's give them a round of applause. I think we can leave now. Yep.
All right, thank you so much. I think they deserve a really big round of applause. And thank you, Cassandra.